So the next two graphs we're going to build are tan and cotan. And I want to do them together on the same page because they're very similar and yet very different. So again, we're going to start with our quadrantal angles. So we've got the tan of 0, and let's just do one at a time. So we're going to start with tan. So the tan of 0 radians. Now we're y over x, which is going to change things. So my y value is 0, my x value is 1, which means the tan of 0 is 0. Okay, let's move on to pi by 2. The tan of pi by 2, we're moving up to here. We have a point 0, 1. Again, it's y over x, so it's 1 over 0, which is undefined. And what do we do when a graph is undefined? We draw an asymptote for this one. So at pi by 2, we're going to have an asymptote. Then we're going to move to tan of pi, and we've got a point here, which is -1, 0. And again, it's y over x, so it's going to be 0 over -1, which is 0. And then we're going to be down at 3 pi by 2. We have a point 0, -1. So if we do the tan of 3 pi by 2, it's going to equal y over x, so -1 over 0, which is again undefined. So another asymptote. And so if we kept going around the circle, now I didn't make this one as big of a grid so we could fit both of them on one page, what do you think would happen next? At 2 pi, we're back at 0, right? If this kept going, we would just alternate between x-intercepts and asymptotes. So if I went the other way, if I went in a clockwise direction, from 0 to -pi by 2, at -pi by 2, it's the same as 3 pi by 2, which is undefined. And again, I'm going to alternate between x-intercepts and asymptotes. So at -pi by 2, I have an asymptote. At -pi, I have an x-intercept. At -3 pi by 2, I have an asymptote. And at -2 pi, I have an x-intercept. Now let's just continue with this. I'm not going to finish graphing this right now. I'm going to continue this theme and switch to cotan. So let's start with the cotan of 0 radians. Instead of being y over x, I'm x over y. So it's 1 over 0, which is undefined. So instead of having an x-intercept at 0, I have an asymptote. And then what do you think is going to happen? The cotan of pi by 2, now we're back up here, we're x over y, we're 0 over 1, which is 0. And then at pi, what do you think will happen? Well, the cotan of pi is x over y, so -1 over 0, which is undefined. And so this guy is also going to alternate between asymptotes and x-intercepts. And so I'm just going to keep drawing those. So at 3 pi by 2, I have an x-intercept. At 2 pi, I have an asymptote. At -pi by 2, I have an x-intercept. At -pi, I have an asymptote. At -3 pi by 2, I have an x-intercept, and at -2 pi, I have an asymptote. So this is setting up the framework for these two graphs. And so what I want to look at next is, well, how do I sketch this? Well, let's look at something in the first quadrant. In the first quadrant, we have an angle like pi by 4, right? So if we make this pi by 4, we know that, I can't write in there. That's supposed to be a pi by 4. Pi by 4. So if we know if we have an angle of pi by 4, it's my 1, 1, root 2 triangle. So if we think of tan as being y over x, it'd be 1 over 1, or opposite over adjacent, it's 1 over 1. And so we'd have this value for tan of what? Well, it's 1. It's positive 1. So in the first quadrant, tan of pi by 4, so tan's over here, pi by 4 is halfway between pi by 0 and pi by 2, we have a value of 1. What about in quadrant 2? So this was my quadrant 1. Now we're going to look in quadrant 2, between pi by 2 and pi. So let's do that same angle. Let's do pi by 4. We have our 1, 1 root 2 triangle, but this time the x direction is a negative direction. So instead of being positive 1, it's going to be negative 1. So at, what is that? Pi minus pi by 4. So 3 pi by 4, so halfway between pi by 2 and pi, we're going to go down to negative 1. So in the second quadrant, and if we think about CAST as well, right? In the first quadrant, tan was positive. We were up here. In the second quadrant, tan was negative. We were down here. In the third quadrant, tan will be positive. So if you think about it, I mean, I can draw it as well. If we drew our triangle, the key thing is that the y value is a negative as well. So it's negative 1 over negative 1. So I'm back up to positive 1. So tan is positive in the third quadrant. When we move on to the fourth quadrant, which is this guy here, tan is negative. And if we were to draw the triangle, we'd realize that the opposite is negative 1, but the adjacent is positive 1, right? Or the y value is negative 1 and the x value is positive 1, but we're down to negative. So what does that mean for our graph? Well, if you think of these graphs having asymptotic behavior and passing through an x-intercept, if you think of graphing rational functions, we're going to pass through the x-intercept, but we're going to approach the asymptote. So in quadrant 1, I'm going to approach the asymptote in a positive direction. In quadrant 2, I'm going to approach my asymptote in a negative direction. In the third quadrant, I'm going to approach my asymptote in a positive direction. In quadrant 4, I'm going to approach my asymptote in a negative direction. And this shape would continue. So if I went clockwise, I'd be approaching in a negative direction. In quadrant 3, right, almost between negative pi by 2 and pi, I'd be in a positive direction. Now I stopped doing the ones. I guess I should put them in there. We only need sketches of these. You just have to understand where they kind of go. Down here at negative 1. So quadrant 4, quadrant 3, quadrant 2, and now I'm in quadrant 1. I'm going to approach my asymptote in a positive direction. So the shape of a tan curve kind of goes from down to up, I always call these, right? It reaches for the stars. It approaches your, like if it goes through your x-intercepts, and then it goes from down to up. So from negative to positive, from negative to positive. What's going to happen with my cotan curve? Well, in quadrant 1, cotan is the same as tan, so it's positive. So it's going to be at pi by 4, it's going to be at positive 1. And then in quadrant 2, which is right here, I'm going to be negative. So I'm going to be at negative 1. So what's that going to do to my shape? Well, from pi by 2 to 0, right, when I'm approaching this asymptote, I'm going to approach it in a positive direction. And in quadrant 2, I'm going to approach in a negative direction. And this is the shape I'm going to get. So in quadrant 3, cotan is positive. In quadrant 4, cotan is negative. And this one, I feel like the shape, well, not that it makes more sense, but I find that it kind of just like is easier to do because there isn't this weird, like I start at a half of the graph. You know, the asymptotes are at 0, pi, 2 pi, and so on. So it kind of just makes it easier to figure out everything in between. And then I can just keep the shape going. So I'm going to put my little dots to guide me. I'm going to go from up to down. So it's sort of the reverse graph, right? Instead of going from negative to positive, it's going from positive to negative when you read from left to right. Awesome. So that's the difference between graphing tan and graphing cotan. Now what I want to look at is the features of these two graphs. Oh, I just noticed I stopped writing. Cotan of 3 pi by 2 was what? X over y, 0 over negative 1, which was 0. And then I think we were back to 2 pi. Okay. All right, so let's look at the features. Now I've cut down the features a little bit. The amplitude. Amplitude is the absolute distance from the center line to the top or the bottom of your curve. And so for the sine and the cosine curves, they went up to 1. These ones are infinite. So tan and cotan are both have an infinite amplitude. They don't have an absolute top. The center line for these, again, is going to be y equals 0. So every single graph we do until we transform it will have a center line at y equals 0. Now let's talk about the period. The period of a tan curve is from asymptote to asymptote, because that's the time for one of these cycles of down to up. And so negative pi by 2 to pi by 2 is a distance of pi. You could also look at it from x-intercept to x-intercept. But the period of a tan curve is pi, and it is for a cotan curve as well. Now the x-intercepts. Here is where people can get tripped up. But what I want you to know is that if you know your x-intercepts for your sine curve and your cosine curve, then you know it for tan, which is why for the rest of this course, like as when we start transforming these graphs, we won't actually be graphing tan, cotan, cosecant, or secant, because if you know the features of sine and cosine, you know the features of all these other graphs as well, because there is a thing that states that tan theta, actually maybe I'll write that lower down. I don't want to take all that room. Tan theta is equal to sine theta over cos theta. Okay, this is on your formula sheets. So sine theta over cos theta, so whenever your numerator equals to 0, you get an x-intercept. And whenever your cos theta is equal to 0, you're going to get an asymptote. Your graph is going to be undefined. So we can then figure out our x-intercepts. Our x-intercepts for our tan curve are the same as the sine curve. So if you remember, sine was a graph that kind of started here and it started here and went through. So my first x-intercept was 0 and then pi and then 2 pi. So my x-intercepts are every n pi. But then my domain, all right, NEA, right? But then my domain is everything except where cosine is equal to 0. Now cosine is equal to 0, if you remember, it starts at pi by 2 plus n pi, where n is an element of the integer system. So I always do my domain in set notation for these because it's just easier. Like if you tried to do interval notation, you'd be like, x can be everything between this and 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 this, and it would be endless. Whereas if you just say, hey, x is everything but, you know, wherever cosine is equal to 0, it's a heck of a lot easier. And then the range is negative infinity to infinity, right? Or x is an element of the integer system. Now, if we look at cotan, it's the same idea. So cotan of theta, instead of being sine over cos, is cos theta over sine theta. So the big switch is that now everywhere cos theta is equal to 0, you get an x-intercept. And everywhere sine theta is equal to 0, you get an asymptote or a restriction in your domain. So these two things will switch. Now my x-intercepts will start at pi by 2 and happen every n pi. And my domain will be that x cannot equal n pi. And so as long as you know these two things, you can use them for all of these curves. And then, you know, my range would be negative infinity to infinity, or y is an element of the real number system. I don't know what I was doing here. Somebody walked by my office when I was writing this one. This one should be y is an element of the real number system. That was bizarre. All right, so that is graphing your tan curve and your cotan curve. And again, we aren't going to be transforming these. I just want you to sort of understand the basic features of them and how they are really just based off of your sine curve and your cosine curve.